Our essential question for this week is, how does the arrangement of the periodic table help us predict the properties of the elements? Another name for properties is characteristics. So really what we're going to be looking at is, how is the periodic table organized or arranged, and what does that tell us about the characteristics of the elements? Well, we already said that one of the ways the periodic table is organized is by groups and periods. And we said that elements in a group share similar properties, which means that if the elements are in the same group or the same column, then that will give us a really good prediction as to what the characteristics of all of those elements are. So here's how you're going to make your periodic table that's glued into your science notebook. You need to do three things. One, you need to number and label groups and periods. You need to color the different categories, and you need to make a key for the colors that you create. And what I mean by key is you need to tell me what red means. So like if you color a group red, you need to tell me that red are the alkali metals. Before we get into what you're coloring and why, here's a quick review on the categories of the periodic table and how it's organized.
The periodic table is also organized by color into different categories. These categories are organized by properties of the elements. Alkaline metals like sodium often react with water to produce alkaline solutions. Alkaline earth metals like calcium also produce alkaline solutions when combined with water and are found all over the place on Earth. Transition metals like iron are strong and shiny. Ore metals such as lead are soft with low melting points. Semimetals like silicon conduct electricity only under certain conditions and are useful in electronics. Nonmetals have a variety of properties and include the carbon, nitrogen, and oxygen vital to life on Earth. Noble gases like helium and neon have outer electron shells that are full, and so they don't often react with other elements.
So that was a quick review from the Brain Pop you watched the night before. So get these colors ready to go, and you're going to make this key on the top or the bottom or wherever you have the most space on your periodic table. So you're going to color group number 1 red because these are the alkali metals. Now be very careful because hydrogen is actually not an alkali metal even though it's categorized with group number 1. So hydrogen will be colored green with the other non-metals that are over here, carbon, nitrogen, oxygen, the ones that are essential to life on Earth. So alkali metals in group number 1 are red, except for hydrogen. Then group number 2 are called the alkaline earth metals. Groups 3 through 12, and then these elements down here at the bottom, we're going to call the transition metals and other metals. Transition and other metals. We're going to color that yellow and make your key. All of these elements right here, including the metalloids and some other metals down here, we're going to call the metalloids and poor metals, and these will all be colored purple. Once again, these non-metals right here, 1, 2, 3, 4, 5, 6, 7 plus hydrogen will be green. These are the non-metals. Now, one category that the Brain Pop did not mention that you need to know is a category called the halogens. Halogens are these 4 elements in group 17, and they will be colored orange. And then in the final group, group 18, these are all considered the noble gases. So you need to make sure that you are coloring these accurately. And while you're writing or coloring, let me just give you a few tips or some facts about some of these elements. Everything in group number 1, because it only has 1 valence electrons in its outermost shell, is considered very reactive. Hydrogen is very reactive, and even though it's not a metal like the others, it's put in with the same category because it has similar properties. Lithium, sodium, potassium, all of these elements are very reactive, very explosive. Lithium, sodium, potassium, rubidium, all of these will explode if you put it in water. Coming over here to the noble gases, however, the noble gases, all of these elements have electrons that are full on the outer shell, which means these are not reactive. Helium, neon, argon, krypton, xenon, all of these elements do not react with others because they are considered, or they have outer shells that are full. Now the halogens are all elements that have 7 valence electrons, which means they are just 1 electron shy of being completely full, which makes these very reactive, but they are non-metals. And one of the things that's interesting about the halogens is, for example, chlorine. Chlorine has 7 valence electrons. Well, sodium has 1 valence electron. Sodium and chlorine bond together very well, and sodium chloride is actually what creates your table salt that you put on all of your food. So you take an element that's a metal that's explosive in water and a green poisonous gas, you put them together and an electric reaction or a chemical reaction happens and you get table salt, which actually you have to have in a certain amount of your foods in order to survive, which is really interesting. So pause this video as much as you need in order to make sure that you color the periodic table that's in your science notebook, and email me or message me if you have any questions.